Hi, I'm Megan, and this is Module 1, Question 2, Substring Match. The agenda for today in this particular question will be broken down into 4 sections. The first one will be Understand, the second one will be Brainstorm, the third one will be Solve, and the fourth one will be to Improve. Now let's go to Understanding. So to begin with our problem statement, we first want to understand the important details in our problem statement that's given to us. So in our problem, we'll say, suppose you are given an array of strings, str, and return all strings, highlight that, in str that is a substring of any other string in str, such that all returned strings have the same length. And that's one of the most important parts, hence why it's highlighted orange. So when you find your match substrings in that array str, they need to all have the same length in order for them to be returned. So that's the one catch about this problem. Lastly, you could return the answer in an array of matched strings in any order. And for the sake of defining a substring, just remember a substring is a contiguous sequence of characters within a string. The constraints within this problem will be that all the strings in str are unique. Stri contain only lowercase English letters, so you can expect each word in str, the array that's going to be passed in, will contain only lowercase letters. And likewise, with that fourth constraint, you can expect each word, the length of each word, to be greater than or equal to 1. The actual str array will be between 0 and 100 inclusive. Now let's move on to test cases. So we have 5 test cases for this problem, all of which will have a different amount of strings and all of which will deal with particularly strange edge cases. So the first one, test case number 1, will have 4 strings that'll be place, misplacement, great, and greatest. The output for this test case will be place and great. And that's because we have place over here, which is a substring of misplacement, and we have great down here, which is a substring of greatest. So although these substrings are matched as substrings within our array, we do need to check the length. And notice that the length of both substrings, place and great, are 5 characters. So 1, 2, 3, 4, 5 for place, and the same for great. And because of that, we have 2 substrings of the same length, and that's why our output is that. For the next test case, we're going to have 3 strings passed in, 2 colors, red, blue, and RD. So 3 strings, and our output for this case is going to be empty, nothing else. And that's because this is a specific test case where we're dealing with an edge case. So in this example, we're going to be returning an empty array because there are no substrings, first of all, in that array that's passed in. And because there are no substrings, we don't have any match strings at all. So we can't really compare any sort of length. So we return nothing because there are no substrings, so we cannot compare. For our third test case, we are going to have 5 strings with some superheroes, Bat, Batman, and Batmans, as well as cat and category. So you'll notice that Bat is a substring of Batman, and Bat is also a substring of Batmans. You'll also notice that Batman is a substring of Batmans, and cat is a substring of category. So we do have 3 matched substrings, and they're all valid, but not all of them share the same length. Remember, that's the catch in our problem. So you can't return anything. That's why the output is empty in this case. And for our fourth test case, we are going to have 3 strings passed in, and that will be sing, Singapore, and singing. The output should actually be sing, not singing, so this is a little typo. And I'm going to show you why. So sing is actually a substring of Singapore, and you'll see that it's a substring of singing as well. So that's our substring. And we would be returning sing, not singing, because we have one valid substring and we have no other substrings to compare that length to. So we are only going to be returning sing because there are no other substrings to compare the length to. And our last case is an edge case. If we were given an empty array of no strings whatsoever, our output, of course, would be empty because the given array str is empty. So for our next section, it'll be brainstorming. And with brainstorming comes pseudocode. So if you were asked in a technical interview some sort of question, the first thing you should do is not only understand, but brainstorm a solution. And with that, we are going to go into the pseudocode for our first solution to the problem statement. So let's start with our pseudocode slide. First, we will initialize the array result, which will act as our storage container for our match substrings that we find. Then we will iterate through each word in the array str, which will be passed in, to compare two separate strings with each other. So if we had an array, let's say we had an array of bat, Batman, and it's not letting me do a quotation mark there, so we will do ... So we want to compare these two strings, for example, and we're going to continue within that loop by iterating. And by loop, I mean a for loop as a little hint besides the pseudocode. Next, we'll check to make sure we are not comparing the string with itself, because we absolutely don't want to do that, and that one string can be found in the other because we need a substring first to even push back into the result array. And like I mentioned, if that case is meant, we would then push back in the string result. Okay, else we will do nothing. After doing nothing with our else statement, we are going to iterate through the array result of pushed back strings. So those are our substrings that we found, substrings, to compare each one. And when I say compare each one, you'll note that this isn't exactly necessary. And we'll get to that upon our improvement for the pseudocode and solution. So if the sizes with each comparison do not match, so we're constantly comparing and comparing in our for loop, we will remove all of the strings in that result array. We won't even continue, we'll just remove it. If that's not the case, we won't do anything, just like we had over here. So we're kind of focusing on two actions, the first being pushing back our substrings, and the second being checking the sizes, the length of our substrings. And lastly, we will print the found substrings in which they all have equal length. So let's get back to solving our problem. The problem statement is there to the left and some sample test cases as well that we went over. I'm going to start, like we mentioned, initializing an array or vector. I personally prefer vectors because they help prevent things like crashing and exceptions, as well as general errors. So let's start with a function. I'm going to do void, do string match naive, because that's going to be our first function, and if you remember, we're going to improve upon it. So let's pass in a vector. And let's also pass it by reference. Oopsie. Okay. And let's call that str. And then we will have vector int reference, and we'll call that result to store all of our substrings. Okay. So now we've got a function, and we want to iterate through our str vector. To do that, we are going to use a for loop because we want to touch every single element in that vector. So let's do for int I is equal to 0, I is less than str size, then I plus plus. And again, in order to touch every single and compare our words in str to determine if one is a substring of the other, we want to use a double for loop. So do int j, basically the same structure. We're going up until the vector size. Okay. So now we've got the basis for iterating through our str vector. And as mentioned in the pseudocode, we want to start comparing to find our substrings. So in order to do that, let's make an if statement with a condition. So remember when we said we didn't want to compare the same string with itself? So how about we did if I is not equal to j, meaning we're not comparing the same string with itself because the indices need to be different. If I is not equal to j, and this is where we use our find function, strj dot find stri is not equal to string and pause. All right, so let's start by explaining string and pause. Typically, let's write a comment for this. String and pause means we haven't found our string, because string and pause by itself means the end of the string or until the end. So we sort of reach up until the end without finding anything. But since we're negating it over here, this not equal to sign, that means we haven't not found it yet. And likewise with our indices, I is not equal to j, that means we are not comparing the same string with itself. And instead of we haven't not found it, how about we say, and we found the substring. Okay. So we see some complaints in our program. Let's see and debug it. So how about we open up the errors? Okay. Seems I'm missing a brace, which would be over here. So that's one error gone. And base type int. Let's see where that is. So it would be right here. Okay, so that's entirely my bad. I had made a little mistake in passing in my parameters. So let's recap what I just did. Essentially, I am passing in two parameters or two arguments, and that will be a vector of strings and another vector of strings, both of which will be called different things, so str and result. Then I'm just iterating through str because that's going to contain all of the strings, the initial strings. And finally, I am making my comparison if statement to make sure we found that substring and we're not comparing the same indices with itself. Okay, so we have our if statement, and if this is all met, that would mean that we found our substring and we're dealing with two different strings. So how about we take our result vector and we use the pushback method, result pushback, and we push back, let's move that, stri, because that was found in strj. Okay, so essentially this entire function, let's write it over here, compares our strings and finds substrings. All right. So that's not the end of a problem. We have, let's see, we want to find all of the substrings and we want to see if all the return strings have the same length. So you can remember, for example, in example 1 where we have 4 strings, place, misplacement, great, and greatest. We are returning place and great because they both have the same length. And remember, if we find any sort of substring, they all need to have the same length in order to be returned, in order for that to be our answer. Okay, so all of this does, this if statement, is it just gives us our substrings and puts it back into our result array. So the one thing we're missing is to compare the length to get our final answer. So let's get started. And remember, we want to iterate through this again, but this time we're iterating through our result vector because that contains our matches. So for int I is equal to 0, I is less than result dot size I plus plus. For int j is equal to 0, j is less than result.size j plus plus. Okay. So we've got our double for loop. Let's make sure I didn't mess up any syntax, and I didn't. All right, so now we want to, let's do two comments. We want to iterate through our results of substrings. And over here, we want to compare the length. And over here, we're going to compare the length of all substrings that we find. How do we do that? So how about we do if stri dot length, instead of dot length, it might be dot size. Yes. It's not equal to strj dot size. And just a quick check, instead of str, we will be dealing with the result vector. Okay, so we have our if statement, and this essentially means that we have a size conflict. So if we have a size conflict, then we have two substrings that aren't the same length. So we know if we have two substrings that aren't the same length, we're not going to be returning anything in the first place. So how about we do result.clear to clear our vector of quote-unquote answers, which are no longer our answers, and then we'll do a return statement. Okay, so this is our solution. To recap through it, remember our pseudocode. We iterated through our str vector. We compared the strings and tried to find substrings. We pushed back our substrings into our result vector. And then when we had our result vector, we created two other for loops, a double for loop. And then we have an if statement to check the length. And then we are going to result.clear if the lengths are different. In other words, if there's a size conflict. All right. So how about we test this out? I have a test case 1 over here where I have initialized my vector result. Over here, I will have a vector of strings called case 1, so it will be equivalent to this example 1. And I will pass in string match naive. I will pass in case 1 and result into that. And essentially, this display vector function is just there to display our strings. So let's go ahead and do this. So we should get back, which is on the right, place and grade. Let's see if we get that back. Okay, so we don't get that back, so let's go ahead and start debugging. We have string match naive. We passed in our case 1 and our result vector. We're displaying our result vector. Place, misplacement, great, and greatest. Okay. So we have two vectors. We have our iteration. We make sure they're not the same string. We find the substring. Then we push it back, that substring. Then we do another iteration with another double for loop. And iterating, we check if the sizes aren't the same. And that's when we clear our result. All right, so what we're going to do now is start with debugging, because you can see that if I run this, I actually won't get anything, and our output for case 1 needs to be place and grade, and you can see that I'm not getting a thing. So let's go line by line. Let's start line 7. I have my function. I iterate through my vector. And it will be a syntax error. So let's change this. And let's run it again. Okay, so we've got our correct answer, but just in case, let's try one more test case. How about we try, let's do let's create a vector of strings, of course. We'll call it case 2 in this case. And we will do red, blue, and RD. In this case, we should not return anything. Okay, we'll pass that in. Case 2 in our result vector to capture everything. And we will finally display it all. Okay, so let's do this. All right, perfect. So we didn't get anything, which is exactly what we wanted. Our output needed to be empty, and that's because, again, there is no substring here, so there's nothing to compare that substring's length to. Okay. And for the sake of just checking that syntax error, it should be absolutely correct because there are really no other errors besides the J++, which should have fixed everything. We will try one more test case, which is our superhero one. We'll have Batman's, we'll have cat, and category. And I'm trying this one because it has the most amount of strings. We'll pass in case 3, and in this case we should not receive anything. Okay, awesome. So our solution works, and remember, upon debugging, this was actually I++ and not J++ as it should have been. So if you ever need help with debugging, make sure to check your for loops. And now that we have done our first solution, let's try improving it. In other words, that is our last section for this video. So an improved solution means that we're not going to have a lot of this. It's going to be a lot more condensed and more efficient. So let's copy this. Let's paste it. Let's comment this out. And let's start editing that solution. Let's call it string match better. We'll still be passing in everything. We still need to iterate through our str array. We still have string and pause. We still want to make sure we're not comparing the string with itself. And in that case, we would result push back. But we don't want to add more, such as 2 other for loops. So how about we get rid of this completely? Let's be brave. Okay. So let's start over here because we know for sure that we need this. We want to make sure that we're not comparing the string with itself and that we find the substring within the other word. So let's make another if statement in this case because we still want to say we have checked the length in order to finalize our result vector. All right. So let's comment this out. Now let's make another if statement, and we will say, we first want to check if our result.size is equal to 0, so if it's empty, and if it's empty, we're going to push back our first word into it. Or, so we will have our or statement, and we want to check the length, so we'll check one of the strings, and we'll check the size of that because we want the size. And we want to make sure it is, let's say, equal to results.i.size. And if that is the case, see, that means we have an empty result vector. Then we want to result.pushback stri. And this means that if we met the conditions, we have a substring. And not only do we have a substring, but we have a substring with the same length. So we didn't need to do another double for loop, creating 4 for loops and adding to our time complexity, which we will go over soon. All we really needed to do was create another if statement. So upon that, we can test it. We have string match better. Let's double check our solution. We have result.pushback. That's all correct. Let's make sure we're clearing it as well. Okay. And we need a return. Oh, all right. So in this case, we will be doing string match better. If we come into a problem, we will just debug it. So we are doing example 3. How about we do case 1, our first one, which is place, misplacement, great, and greatest. So we'll get rid of this last string. We'll pass in case 1 and result, then we will display our vector. Let's go ahead and run this. So this should give us place and great, but it doesn't, so we will need to debug it. So let's see, if this isn't met, that means that we have a size conflict. So we're checking if, let's do another if statement. If the result vector is empty, then we want to push back our first element. Then we check or the size of str is the same as results size, so comparing words. And if that's the case, we push that back, and we're pushing back stri because that's the one with the same size. So after that, let's see what we've got. All right, so we have that the size of str is the same as result size, a word comparison, and let's continue. Okay, let's try running one more time. Okay, so you see that we get nothing, and that is for case 1 in main. So that means we have to debug a little more. Let's go line by line. We have our for loops. We have our indices not being the same and finding a substring, so that should be good. And we have, let's see, the result vector is empty, then we push back our first word, or this or statement, the size of the word is equal to result dot, oh, there it is. Okay, so instead of I, what we are going to do is replace that with 0, because this actually needs to be our efficient solution. And why we're changing it to 0 is because we want to compare all of the words with the first word in our result array. So we have result 0, and that's essentially going to be comparing, do result 0 is comparing the words in str, the length, to our first result string. Okay, and we can do this because we know that we have to end up returning our result vector or array with strings or substrings of all of the same size, all the same length. So we can automatically assume they're all the same length, so we can just use the first string we have in our answer, our result vector, and that would be at index 0. So we're just going to compare all the words with that one instead of comparing them all together like we were doing in our more inefficient solution. So notice that we don't have an additional 2 for loops. So we have 2, we have 4, and in our new solution that's better, we only have 2 for loops. Okay, so let's check this out. Okay, so you can see that we're printing place and great, which is exactly what we want. Let's try another test case. We will do test case, how about we try 4, where we have sing, Singapore, and singing. We'll erase that. We'll pass in case 4, and that should be it. Okay. Let's see, and it gives us exactly what we want, which is Sing. And that's because Sing over here is a substring of Singapore and singing. And since we only have one substring, that means we don't need to compare it with the length of any other substring. So that's exactly what we want. Now, in terms of an inefficient and efficient solution, what you could do is take a look at this first solution. In terms of time complexity, but remember that time complexity is very theoretical. We have two for loops, so that would give us n squared time. We also have the find function in C++, so I will do k is the max string length because that's important as well. And we have an additional two for loops. That will be another n squared time. It's quadratic. Okay. And finally, we see if there's a size conflict and then just clear it. For a bigger picture, our time complexity for our inefficient solution would end up being O kn squared plus n squared, which ends up simplifying to O kn squared. Okay, so it is quadratic, but let's look at our more efficient time complexity. So we have two for loops, so that would be n squared time. We have an if statement using the find function, and we still have k as the max string length. So remember, k is max string length. So since we keep the first section pretty much the same, we will do O kn squared. And lastly, we just have, let's see, we have our find function and our if statement. So that essentially means that instead of having n squared, like this double for loop, we are just going to have n. So you can see that instead of having another quadratic, an n squared, we end up having n. And although both solutions end up being quadratic, you can see that the second one is a lot more efficient, it's cleaner, and it's faster if you were to benchmark this solution. So that's basically it in terms of our two solutions, one being inefficient and efficient, and how the time complexity differs between each solution.